Okay, this is the second part of solving quadratics with quadratic formula. What I've got set up for you is just some early notes on one of these application problems where we have a little bit of a real world scenario. I've highlighted the formula that we're going to use for acceleration, keeping in mind that these objects are following a parabolic path, so they are launched or whatever has caused them to take their path. They go up to a maximum height and then they return back down. So in that parabolic pattern, like I'm showing you here, this is what we're talking about items doing. So they're getting launched anywhere along here and then continuing to a max height, which is the vertex, and then eventually landing on the ground or where the height is no longer higher than zero. All right, so what we're going to do is going to talk about how to do this. Still going to use the quadratic formula on this quadratic equation because this is a quadratic. You see the highest power is 2. Keep it in mind that in this problem they talk about finding the maximum height. Remember that the maximum height is the vertex, so we're going to try to find the vertex. The vertex formula is the opposite of b over 2a, and again the coefficients right here, a is negative 16, b is positive 16, and c is 480. I've also made note that 16 feet is the same as 4.8 meters. So whatever the scenario is when I'm doing acceleration, when I'm talking about meters, I would use the a value is going to end up being 4.8. If I'm talking about feet, which I am here, the a value is going to be negative 16. All right, so let's figure out what our vertex is and then continue the problem from there. Okay, so the opposite of b in this case will be negative 16, and then 2 times the a value of negative 16. So that would be negative 16 over negative 32, or 1/2. So the x value when I'm at my vertex is 1/2. Now keep in mind that that means that this is 1/2 or 0.5 seconds. So I actually haven't answered A's question yet. I've answered how long it will take to get to the maximum height. Now what I'm going to do with that x value is substitute. Now we're treating it like x. It's also t in this problem. So that's the time. So I'm going to substitute this 0.5 in for t. So everywhere I see a t, I'm going to put 0.5. So I'm trying to find out what's the height at 0.5. So h is negative 16 times 0.5 squared plus 16 times 0.5 plus 480. Okay? So what you could do in your calculators, you could type that in to make sure that you get that correct, unless you can do that in your head mentally. So I'm going to go ahead and figure this out real quick for us. Okay, 0.5, and I'm going to square that, and then I'm going to multiply that by negative 16, and I get negative 3. So then 0.5 times 16, that's 16 divided by 2, or 16 times a half, and I get 8 for that, plus 480. Now that's going to give me negative 3 plus 8 is 5. 5 plus 48 is 53 feet. So the maximum height of this function is 53 feet. So when Jason jumped off the cliff in Acapulco, his max height was 53 before he started his descent down to the water. All right, next, what was the highest point that Jason reached? That was 53. So how long did it take? Was this 0.5 seconds? And then what was his maximum height? And I drew this arrow in the wrong place. His maximum height was at 53 feet. Next, Jason hit the water after how many seconds? Well, one of the important things to realize, and we'll go back up here and look at our picture, if the cliff is, say, somewhere here, and Jason jumped up and then continued down, the water is right around here. Well, what's the height of the water? Well, the height of the water is 0. So What I'm trying to figure out is how long did it take for him to reach a height of 0. So h is my height. So what I'm going to do here is I'm going to substitute 0 in for h and solve for t. Essentially, I'm solving this quadratic equation. So 0 is equal to negative 16 t squared plus 16t plus 480 rather. And so my coefficients are negative 16, b is 16, and c is 480. I'm going to go ahead and solve using the quadratic formula. So my x values will be the opposite of b, so the opposite of 16 is negative 16, plus or minus square root b squared, so 16 squared, minus 4 times the a value, negative 16, times c, 480, all over 2 times the a value, negative 16. So if you're using a calculator, you could go ahead and type in what's underneath the radical so you can get one number. I'm going to do the same thing. So when I typed in the calculator, I got 30,976 underneath this radical, all divided by negative 32. So I'm going to find the square root of that answer, and I get 176. So negative 16 plus or minus 176 all over negative 32. And now I could split into my two scenarios in order to make sure that I have two answers for my quadratic. So I've got negative 16 plus 176 over negative 32. And I've got negative 16 minus 176 over negative 32. Okay, so now I'm going to go ahead and just simplify here. So negative 16 plus 176 is 160 over negative 32. And negative 16 minus negative 176 will be negative 192 over negative 32. So then 160 divided by negative 32 is negative 5, and 192 divided by 32 is positive 6. So when I think about this, and they're asking after how many seconds will I hit the water, negative 5 seconds means I'm going to have to go back in time, and that's just not possible in real world scenario. So how long will it take after I jump to hit the water? Well, that will be 6 seconds.